All right, here we go. Area of triangles and complex polygons. Ooh, I know you guys love those complex polygons. Now we're going to be throwing some triangles up in it, so I hope you're ready. So first, let's talk about the area of a triangle. Now, I am sure you have seen this before. The area of a triangle is half times base times height. Why is that? Why is it half times base times height? Well, and you don't have to write this down. Isn't it half of a rectangle? If it's like maybe longer like that, you can see it easier. It's half of a rectangle, right? Or it's half of a square like in this picture. So that's why it's half times base times height, half of a rectangle or half of a square. Now, I like to use this right here, so 0.5 times base times height whenever I do my problems. You can use 1/2 if you want. I just think using 0.5 is a lot quicker, and I'm just going to use that. So let's go ahead and get started. Oh, one thing. Your base and your height are always perpendicular to each other. There are going to be some weird problems. They're going to try to trip you up, but I want your eyeball to float right to the perpendicular symbol because that's the only thing you need to look at for your base and your height. Okay, so first let's start with number 1. Pretty easy, right? So our height here is 9 and our base here is 12. And if the area of a triangle is half times base times height, and we know our base is 9, so let's go ahead and pop that on here. We know our base is 9. I'm sorry, our base is 12 for sure. And our height is 9. There we go. Now, if you flip-flop those numbers, it's okay, though. Just to let you know. If we type all that into the calculator, 0.5 times 12 times 9, we will get 54. Now, what are the units here with area? How many dimensions do I have going on here? I got 2 dimensions, right? So, meters squared. All right, I want you to go ahead and do number 2. You can pause this now and do it. You can do it at the end when you're done with all your notes. But go ahead and have number 2 done for class. And you better remember, base and height are perpendicular to each other. Perpendicular. It matters in number 2. Number 3, though, is a little wild and woolly. So we're going to go ahead and take care of number 3 together. Well, you know area is base times height, or half of base times height. All right, so I'm going to go ahead and write that down. Now, the problem is we got to find the base and the height. Height's not too bad, right? Like, this is your height. Let's talk about the base. Now, a lot of my students will tell me, well, the base is this whole thing, or they'll tell me the base is 3, so 3 or 9. Well, it's not, because my triangle's right here. And what is the length of the base of that triangle? 6. So don't get caught up. The reason this is extended out and this is perpendicular, it's because this 5 right here is not a height. It's not a height because it's not perpendicular, okay? So they had to like draw the perpendicular line over here for you to give you the actual height. Later on, we'll call something like this a slant height, but right now you don't use it at all. So the base here is 6 and the height is 4. So the area then is 0.5 times the base, which is 6, times the height, which is 4. So then that's going to be 3 times 4, which would be 12 meters. Don't forget it. Square. Okay, so that's how to find the area of 3 different kinds of triangles. Now let's talk about what we just experienced there. Notice that the height here was pretty easy. When you do this one, hopefully you're going to use this as your height here, and then this height's way over here. So here the height is on the triangle, here the height is inside the triangle, and here the height is outside the triangle. So we're going to fill in this little box. The height can be on the triangle, the height can be inside of the triangle, or that height can be outside of the triangle. So 3 different situations you might find yourself in. But regardless, in every single example, they are always perpendicular. It's a long word to write. Perpendicular. There you go. Okay, so always perpendicular to the base. So let's move it down here to number 4. The area of a triangle 16, the height is 8. What's the base of the triangle? So right here we know that's A, and they said this is the height, so that's H. So if area equals 0.5 times B times H, our A here is 16, and then we have 0.5, and we don't know B, but we know H is 8. Now, a lot of students are like, what do I do here? It looks so weird. Well, the commutative property says that we can kind of rearrange this. So you can do what's 0.5 times 8. So half of 8 is 4, so we have 4b here. And then to get b alone, we divide by 4 on both sides. And 4 equals b. For what? 4 dogs, 4 moons, 4 cats? 4 centimeters. The base is 4 centimeters long. So make sure you do label your units. I got to make sure you know that it's not going to be square because it is just the base, not an area. All right, once you got that, let's go ahead and keep on going. Next thing we're going to talk about today is the Pythagorean theorem. You may have seen it before. We're going to talk about it again today. There's a little bit of terminology you need to know with this triangle. First thing, we only use the Pythagorean theorem if we have a right triangle. We only use Pythagorean theorem if we have a right triangle, okay? So this right here and this right here is called a leg. And students have a hard time figuring out what's a leg and what's a hypotenuse. The legs are always perpendicular. The legs are always perpendicular to each other, okay? And the hypotenuse is the one that is not perpendicular. It's across from your 90-degree angle, okay? It's not perpendicular. So the Pythagorean theorem says that the first leg squared plus the second leg squared will give you your hypotenuse squared. Well, in our picture here, we have a squared plus b squared equals c squared. By the way, random fun math fact for you, Pythagoras, he thought that the perfect number was 10. So when you hear someone get called a perfect 10, now you can think about Pythagoras. And you know what, why don't you go ahead and you write perfect 10 up here at the top of your paper, perfect 10, then I know you've been listening to this video. All right, let's keep on going. Use the Pythagorean theorem to find the length of the base. Then find the area of the triangle. Did you read these directions? So first let's find the length of the base, and they said use the Pythagorean theorem. These are the ones perpendicular to each other. So these are your A and your B. Well, this is already labeled B, so this must be A, and that then must be C. So if A squared plus B squared equals C squared, we're going to substitute in the values that they've given us. They said A was 10, so we'll have 10 squared plus b squared. And they said c is 26, so that equals 26 squared. And what you want to do is use your calculator and find out what 10 times 10 is. So 10 squared is 100. Bring down my plus b squared. And 26 times 26 is 676. Now to get your b squared alone, you're going to subtract 100 on both sides, and you have b squared equals 576. How do you get rid of a square? What is the inverse of that? Well, it's to take the square root. So we would take the square root of both sides, and we would have the square root of 576. And when you type that in your calculator, you will get 24. So your base is 24. Have you read the directions, though? Find the length of the base, then find the area of the triangle. So the area of the triangle is 0.5 times base times height. So then the area of the triangle is 0.5. Well, what's the base? And you're like, I don't know. It just says B. But didn't you just find B? It's right here. It's 24. So 24. And then what's the height? Well, that's our A over here, right? That's the height of the triangle. So that's 10. So when we type that into our calculator, 0.5 times 24 times 10, we're going to get 120. Now, you can say units here because they didn't give you anything. And you can say units squared here because they didn't give you anything. I can't believe they didn't give you a length. Tisk, tisk. All right, so just to make sure you read the directions when you have a problem like that. Then we get on here to complex polygons. I know that everybody loves complex polygons. You can handle it. It's just a triangle, right? And you've totally got triangles under control. So we're going to go ahead and do number 6 together first. I see a triangle and I see like a square or a rectangle down here. So let's focus on our triangle first. This is my height. What's my base? Well, float your eyeballs down here. The base is going to be the same here and on the top. So if the area of my triangle is half times the base times the height, then the area of my triangle is half times my base is 12 and my height is 8. And when I type that into the calculator, I get 48. And it's going to be meters squared. I'll write that down at the end though. The next one is this shape right here. And the area of this would be base times height, or hey, did you notice it's a square? You could say side squared if you want to. I don't use base times height, that's just my style. So area equals 12 times 12. And then 12 times 12, when you type that into the calculator, is 144. Now, this is a complex polygon, so what they want you to do is they want you to add these together. Okay, so 144 plus 48 is 192. We're dealing with area, so it's going to be meters square. All right. I would like you to do number 7 for class, so bring number 7 to class with you, all completely done, and let's see if you got that problem right. It looks like it's just a rectangle and a triangle. Did you notice this says not drawn to scale? Don't try to eyeball stuff. Even on the ACT, not everything's going to be drawn to scale, so don't eyeball it. Ooh, let's go down here to this. Doesn't that look really cool? Aren't you like super pumped about this one? It's going to be super easy, so I hope you're not worried about it at all. So first let's start with this. It's a square, right, which is a type of rectangle, and since it's a type of rectangle, you can use base times height. You can also use side squared, whatever floats your boat. So here our base is 5 and our height is 5. So the area for this one right here would then be 25. Okay, let's keep on going. Let's go on to this shape right here. Now this is a triangle, so I know that the area is 0.5 times the base times the height. But we are in a predicament here because I can see my base is 5, but what is my height? And my height right here will be the same as this length right here. So my height is going to be 5. So then the area is going to be 0.5 times 5 times 5. And when you type that all into the calculator, your area is going to be then 12.5. Okay, that one's done. And then last but not least is this one. And since a square is a type of rectangle, I can call it base times height. You can say side squared if you'd like. This is going to be 7 times 7, so our area here is going to be 49. All right, now once you have all 3 of these pieces done, you've got to take all of them and you add them together. And if you type those into the calculator and add them all together, you get 86.5 feet square. Okay, so make sure you write the square on there. All right, that's it for the video. I hope you enjoyed doing some complex polygons and learning a little bit more about triangles. Make sure you finish those problems up that I asked you to do, and I will see you in class.